Welcome you all for the day 2 training, and today we'll be learning some of the interesting concept of next moving level, how you can use the sketcher workbench in a very precise manner, and some of the doubts where few of them were having in terms of understanding the sketcher workbench, where I'm going to cover today the importance of sketch analysis, why are sketch operations, what are the different types of sketch operations, what are the different formats of profile creations, and how these profile creations are going to impact on your design aspects, right? And how the sketch analysis will play a very critical role in understanding the sketch constraints. Yesterday we discussed about the sketch constraints, right? And how the sketch analysis will enable you to move on to the next level in terms of the features based design, that is nothing but your sketch based feature. And we all know that unless the sketch based features, the sketch is not fully constrained and not having any ambiguity in terms of the profiles or the sketches, you will have major challenge. So to enhance the ability to make the sketch fully confined and constrained with reference to your design aspects, we will learn some of the sketch analysis. Quickly we'll get into our objective of the day. So let's get into the applications, where to start with, yesterday we discussed about the different aspects of the processes. Number one, we understood what is my sketch. So currently we are in part design. To get into the sketch, we need to get into my sketch and select your plane. So this is your objective, right? And now once you get the sketch, you get these inputs. And somebody was asking, the moment I create a sketch, when I get a pad or pocket or whatever feature, you get some messages. All these things I'm going to cover down the line, because that is a structured way of learning we are having it. So as we see that in this particular group, all are first time users. So that is the reason I'm going by step procedure. Okay. So the first step for us, I'm going to even delete this one. So let's get into my first step of creating the sketcher. Go for sketch and find out this is my sketcher workbench. So today's task, let's get into this one. Today's task is that let's go and create this model. So the objective for me is to create the sketch. And when you start creating the sketch, understand the criticality, the dimensions, the first important thing, right? In this case, what are the dimensions which I need to do it? The moment you want to create any of the basic fundamental sketch, first understand that what are the dimensions with reference to this absolute axis. Say for example 340, and this is 85, and this is 100, and this is my 50. So these are some of the critical dimensions which you have it. So now we need to ensure that these critical dimensions have to be implemented in terms of the sketch. Let's get into this one. So the first step is that I'm just going to have this basic sketch first. So let's get all this populated on the top of the screen. So you can see this one, and this is my operations, and this is my sketch tools. Okay, you can see this one. So this is also my sketch tools. So I have sketch tool as well. This is my sketch tool, right? So this is my sketch tool. You can just see this. I just populated over here. So in this case, first what we are going to see is that the same profile, whatever we got it, right? The objective is to create my models. The first one. I'm going to create this one, taking this into account. See this, I'm going to just draw my profile. The moment I just draw my profile, you can see that your sketch tool gets expanded, right? So I'm going to draw to the nearest value. The nearest value is 340 mm, right? So I'm going to just draw it to the nearest value of 340 mm. Just see this one, 340, right? And ensure that this line is horizontal or vertical. So just make it, this line is horizontal. Then I just draw this one. That means this is my angle. See this, in a single sketch I'm drawing all this one. Then I'm just making this profile as well, and then drawing this profile, and ensure that this is also sketched. So it is not normal. So what you do, keep this one and ensure that I'm making normal, so that it's normal. So then I'm going to just draw this profile. So this, and I'm going to just draw this one. See this. I'm going to just draw this profile. Undo is Control Z and just draw this one and join over here. So this is my first stage. So let's go and give the constraint. So this first particular line, I would like to make it fully constrained. So I'm going to use my constraint definition box and ensure that this is my vertical line. And similarly, I would like to select this one and ensure that this line is horizontal, right? And keep it to the nearest value, something like that. My first objective is ensure the longest dimension I'm just fitting first. Always when you start designing the basic sketch, first fix your longest dimension. This is my longest dimensions. So in this case, I'm going to give the longest dimension is 340 as per the day, right? I'm going to give this one as 340. See that? Then I'm going to give this dimension. So just click on this top one and give this one as 100 mm, right? It is given. And the distance between this one, this component, and this one is, see this, the measure the distance between this one and this one is 85. I'm going to make this one 85. And then I'm going to measure this dimension. This is my dimension. So I'm going to make this one as 25, right? And then I'm going to make my dimension of this one, that angle between this one and this one is 30 degree. So which is a missing part? You just see this is missing part. This is flying in space. So what we need to do, ensure that this particular point, right, this particular point, you can see this over here, this particular point and this one are coincident. So what do we do? Select both the one and ensure this point is constant. Now you give constant constraint with reference to this point. The moment you give this constant constraint, you get the sketches fully constrained. Now this is the best process. This is the starting process of the design, right? Now the moment I just go and give pad for this particular sketch, right? I'm going to give pad for this particular sketch. So it takes up. See this? When I give mirror, it takes up. This is my first feature you need to understand. That means this sketch or this pad is driven by, this pad is driven by parent-child relationship, is driven by sketch. So that parent, and this parent is done on YZ plane. So we need to understand that this is my parent-child relationship. So you want to show this one, you can show in the sketch itself. See this? Right? So this is the design. Some point of time, if your design are not meeting the requirement, say in this case, I'm just going to click on my sketch. By mistake, you are making unwanted points. See, this pad is working now, right? When I just go and exit the workbench, you can able to see this pad. But if you have any other ambiguity in the sketch, for instance, a point. I'm just drawing just a simple point on the screen and placing over here a point by mistake. And now you exit this workbench, so it will show you an error, which you can't able to find it. It's very difficult. So what I did, I just created simple point on the sketch. Just Control Z I did. Go to my sketch. I just created a point on this point. I just created a point. Where? This is the point, right? I just created this point. Even that point is not allowing me to create a sketch. That means the moment you go there, you see that this is my sketch issues, right? So you will have those challenges. Unwanted points, unwanted sketches will have a major challenge. So in this case, just check. I'm going to create a point on space, something like this point, white point. By mistake you have created it. The moment you create it, you will throw a message that unwanted geometry is there which is not allowing you to create. The moment you see this one, right? The moment you see this particular sketch, see this, the moment you see the pad having these issues, the yellow exclamatory mark indicates that this pad is having some challenges, issue. What we need to do in this case, we need to ensure that the sketch is fully constrained to go to the next feature that is nothing but the pad. It's not easy to understand, right? Easy to find out what is my problem in the sketch. Let's get into this one. So in this sketch, you have a challenge. That's the reason the pad is not appearing. So now we are going to understand, go to my tools, go for sketch analysis. This is my sketch analysis, which will identify what is my problem in the sketch, which is not allowing me to create the sketch. So that means I'm going to do tools, sketch analysis, which will throw you a message that there are unwanted points. See this is there are unwanted points. This is point number 1. Reframe it. It zooms and tells you there is unwanted point. This point, reframe it. It tells you that this is the unwanted points. See this is unwanted points. So what we need to do these points? We need to delete these points. Unwanted points, I need to delete it. The moment I delete it, you can able to see that your sketch is good enough to go to the next level of pad, right? So what is the intention of me teaching you the sketch analysis is that when you do any profile followed with a base feature or dress up feature, whatever the feature, if you have a challenge on the sketches, it's no way going to take it for the next level of pad features or pocket features or whatever it is. That means always they should have a very clear sketch which drives your sketch base feature, which is free from all flaws, inflections. That means your sketch is something like that. For instance, you just created a profile on this one. I'm going to draw your arc on this one itself. Where? On the arc which you are drawing. See this. We have just created an arc on arc, which is not possible to see by a common man. It's very impossible. The moment you go and create your pad, see, there is a problem. The specified profile contains several open contours or some of the geometrical used for your designs. You must specify the construction geometry to solve this problem and ambiguity. Right? This is your challenge. What do you need to do in this case? Edit. That means this is a problem of the sketch. So now let's go and analyze it. How to analyze it? Go to the sketch. The moment you see this, there is some problem with the pad, don't go with the check with the pad. You see the parent of the pad. The sketch is the parent, right? So the moment you see this parent of the pad, then you just go for sketch analysis. The sketch analysis is available as a command as well. You can just see this one. This also can be available. Now you do a sketch analysis. You can see in this case that unwanted circle is there, open. Always first feature should be a closed profile. And this is not letting you to create your feature pad. I'm going to delete this one, right? So this is the first important aspects which you need to know when you start creating a sketch. So I'll be covering it a little bit more in depth. So this is the first thing which a sketch analysis is a must. So this sketch analysis should be a part of your feature when you start designing. So let's get into our sketcher and understand what are different types of the features which you're going to learn in for the day. Say for example, go for a sketch and click on the sketch. This is my Sketcher workbench, and now currently I'm in Sketcher workbench, right? So I exit this one. I'm in a part design workbench. How you identify that you are in part design? Just go to this one. This also is, most of the people, they do the mistake. That's the reason I'm repeating it. And then I don't want this geometrical set because my settings are different. So let me get into that one. And you see this plane, XYZ plane. I'm going to click on my sketch plane, front view, YZ plane, and go for a sketch. And you can see the grids. The moment you see the grids, you are there in a Sketcher workbench. And you have all your profiles and your operation features appearing over there. So these are my operations, right? These are my operation features. And this sketch based feature and operation feature is so important for you to understand that it's followed by this one. So I'll be covering more on that today. So let's get into this. I'm just going to keep it side by side so that it's understood for you. Right. First thing, profile. When I click on this profile, The first operation you can get it is you can able to create a line. See this, I can able to create my line. Then I can create my tangent arc. Then I can create my 3-point arc. See this. Then I can able to create my line, the active line, or you want to create my arc. Then I would like to create my profile. See this, tangent arc, something like this. And then you will want to create my profile and join this one. So this is the possibility. So that means what? You can able to create your profile using 3 options. One, when the moment you click on this one, you can able to see the sketch tool expands, and the moment the sketch tool expands, you can able to see tangent arc, 3-point arc. Default line will be active, and default, if you want to start with 3-point arc, you can just draw this one. This is my 3-point arc, which I can use it, right? If you want to start with a line, you can just start. But the starting feature of this one, you can't use a tangent arc. Tangent needs either an arc or a line. So starting itself, you can't do that one. So that is your profile. And this we can use even using mouse also. How to create using mouse? The first point you select it. See this? I'm going to select my second point and just drag using like mouse button. Just drag it. So you can just keep moving it using your left mouse button. Right? Just keep moving. Okay. Just keep moving it. Just keep your mouse button and start designing it. So you can just create the model. So this is the model which you can start creating. So you can use any profile of any dimensions using this profile. So, right, using your mouse control, or else you can use directly using the sketch tools. This is one. And I'm not going to cover most of the things, because you know how to create a rectangle and how to create an oriented rectangle, how to create parallelogram. This you need to investigate certain things. So in this case, I'm going to just give you some very interesting ideas. See, for example, yesterday we understood what is the purpose of your visualization tool, right? We understood this one, the purpose of this visualization tool. See this, today let's understand this one. So you know how to create your rectangle. Now I'm going to create your elongated hole. So the moment I just click on my elongated hole, see this, it creates the dimension. So you can see the dimension as well. This dimension is created by default, right? We are not created the dimension using your constraint, right? We are not created this one using your constraint dimensions, right? It is created by default. That means, see this, I'll just repeat once again, right? I'm going to use my elongated hole. The moment I just create and just draw a line, axis line, you can see the geometry. The dimension also gets generated, right? This is my dimensions which got generated. So how it is got generated, that is what we need to understand here. So we have something called geometrical constraint and dimensional constraint on the sketch tool. Let's go and do analysis. The moment you make it off, right? I made my dimensional constraint off in the sketch tool, and I did the same elongated hole. I'm going to do that one. See this? I'm going to do the same elongated hole. You can see you can't create that dimension. It's not visible. See that it's not visible. That means the moment you make it off, the moment you make it this one off, this is blue color indicates off position, you can't able to see the dimension property, right? So very important for you is this, that always ensure this is on. Okay. The moment it is on, when you start creating your line, that means the center axis, you can able to create it. Are you guys with me? Please let me know. Are you guys with me? Any response? Please let me know. Yeah, thank you very much. Yeah, thank you. So now, the moment I make this on, you can see this one, it's on. If it is off, I can just see this. This constraint also will not come. The moment I just make this off, what will be the geometry? Right? The moment I just make it off, sorry, I'm going to draw once again and make this one. See that your geometrical constraints will not appear. Your dimensional constraint is appearing, but your geometrical constraint will not appear. So that's a very, very important fundamental things. So you have to give all these constraints. So always ensure that the moment you create some of the templates, this is elongated hole is a template, right? Cylindrical hole is a template. All this cylindrical elongated hole, everything needs to use it in a ready-made format. Ensure that this is on. That means this geometrical constraint and dimensional constraint on will give you a predefined value. Say for example, the moment you create a circle with a coordinate system, so I'm just creating a circle with a coordinate system, see this, right? I'm creating a circle with 150 and 200, and I'm going to give a dimension of 50 mm, for example. Give it, what happens? You get a circle default with fully constrained, right? The moment you make it off, this one, right, and use the same sketch and give the same value, see that it is not appearing. That means you need to give the constraints once again. So always ensure this should be on. The moment this is on, and now you just create the same coordinate circle with the same value, you can see that the sketch is fully constrained. So that's the point which you need to understand while creating. These are some of the tips and tricks which you should not forget while designing it. Right? So that's the point. So now let's get into the next one. So elongated hole we understood. Now let's go to cylindrical elongated hole. I'm going to teach you something very interesting. Go there. How it works. Just select your center point first. So just put it normal view always. Select your center point, and I'm going to just draw an arc. See this? I'm going to just draw an arc. The moment I just draw an arc, you can see this dimension is getting changed. You can see this, right? You can just fix it. And this dimension is coming because of this value, this is on. Because of this dimensional constraint is on, this value is coming. And because of this geometrical constraint is on, this value is also appearing over here. So that is a point which you need to understand. Now, this sketch is not fully constrained. That means this sketch can fly in space, number one. So what we need to do first, ensure that this sketch is constrained with reference to this one. So I just select this one, make it constrained. Okay. So let's make it constrained. So it's moving on. So that's happening. So let's give the dimension first. So this, I'm just giving it, and this is moving. Okay. So make this one as well. So okay, I just made it off and did it, right? No problem. So it is on now. I'm going to use the same thing. So just select this one and just draw the sketch. Right. So this, it's flying in space. What do you do? Make this one and this one coincident. See this? And make this point. It's flying in space. See, that means it can fly. Give OK. It's flying in space. That means it's moving there. Take this point and make this point with reference to this axis also constrained. You can do anything, right? You can fix it, whatever the dimensions you would like to do it. So constraining is so important in terms of the geometry, very important. Then we have different formats, pentagon, hexagon, keyways. You can just create your keyway as well, right? You can just even create your keyway as well. Just create this keyway. Just see this. I'm going to just draw this one, and you can constrain this one. All these dimensions can be constrained. Sorry. Just draw this one. A ready-made command. So this, you can just create your keyways. All this is happening because of this one, right? Now, similarly, we have other feature as well. See this. We have circle, 3 point. I'm not going to cover all these things because you need to understand what is the use, and this is very much important. Arc. That means when the moment you just draw this arc, just draw this one arc. So this is my arc, right? So this is my arc which can be used for dimensions. Put it normal view, you can able to see this one. This is very much important. So now I'm going to cover some of the operations from which you can able to understand. So this similarly you have spline, you can just create the spline. So I will tell you what is the importance of this spline. So 1 point, second point and third point and the fourth point. When I create it and I just click on this one, the moment I just move this control points, this is called the control points, right? This is my control points. The moment I just move this point, see this, what's happening to the curve. This is called as a B-spline. That means the kernels which is used to create this application is something what we call B-spline kernels. That means the moment I select this point, in earlier days it was not like that. I'm talking about 35-40 years back. When I'm creating points, different points, right? This is one point and this is my second point, third point, fourth point, fifth point. And then when I would like to create a spline using all this point, it will not take earlier time. Right? It will not take because it has a graphic issue. Now your graphics are so good enough that it can take each and every point which you take it. The moment you select this point and make that point available for the next level of action, you can just see this, all these components can be designed in this format. So that means see the curve, how it's behaving the moment I just move up and down, right? So that's very important, you need to understand. So there is an application that is a kernel which is making the CATIA application to run, right? The CATIA kernel name is called as a B-spline, and C next is the exe application which you run this application, right? So that's a computer graphics which each and every organization uses in terms of the coding, right? That's the point which I would like to tell. So then I'm going to just give you some idea about the operations now, very important. See, just observe here. These are all the things which you can able to explore. It's not a big thing. You can have create points, lines, axis system, which we covered yesterday as well. Now I'm going to give you some insight about your profile, which you can understand. I'm going to just draw a rectangle. See this? I'm going to just draw a rectangle, keeping this one as a center. Normal view, and keep it. I'm going to keep it on the center. Right? So this is my sketch. See that it can fly anywhere in space. So first thing is that I would like to make a constraint, right? This I would like to make a constraint. So what I'll do first, take this point, make it constrained with this one. Go select this one, constrain it. And similarly, you take this one, and with reference to this one, constrain it. I'm going to give you some tips and tricks now. So this is my dimension, right? So I would like to give a chamfer, a corner on this one. What I do first, I just go there, take this one and this one, give a dimension, right? And double click on it. I have to give this one and this one, select once again, and select it, double click on it. I have to go once again and select this one and this one, and once again I have to go and select this one and this one. See that this is a tedious job for me, going and giving one by one for everyone, right? So it's not a process which I can do it for each and every time. So it's a tremendous challenge for you to create one by one all the features. So in this case, what we'll do, I'm going to use a rectangular feature, rectangle, and I'm going to make this point exactly coincide with this one and make it constant constraint first. I think there is something happening for me, just a minute. This particular point and this one, I'm going to select it, constrain it, fix it, and see that this is fixed. And now what I'm going to see this, I'm going to fix this dimension, see this, and I'm going to make this dimension as well. Okay, the moment I select this dimension, and I'm going to give this one as 100 mm and this one as 200 mm. Just see this one. Now I'm going to select this one. See, I'm going to select this one. I fix this one in the coordinate system, or else you want to give the dimension with reference to center axis, you can give it. Now what I'm going to do is that I'm going to give this corner, right? I'm going to give this corner. So select this one, first point, then select second point, third point, see the third point, and I'm going to select my fourth point. I selected all these points. First point, second point, third point, fourth point. The first point which I selected over here, right? This is my first point, and this is my second point, third point, and this is my fourth point. So that's a point. The moment I select it and go and click on my operation called corner, and I'm going to give a dimension of 15 mm. The moment I give it, we see that dimension is created all the forms, and it is fully constrained. That means this becomes 15 mm and other becomes formulas f of x. The moment I just go and change this one to 25 mm, the others also get changed. So these are tips and tricks which you need to know how to be very productive in terms of design fast. Earlier what I did, I just selected one by one, one by one, one by one. But what we did in this case, we just selected the first point. The first point which I selected is an editable format. The other points becomes as a default formula, which is nothing but f of x. So the moment I select it and give this relationship and give this dimension, say for example 25 mm, 24 mm, it will ask you the length, trim, all these things. Just give no problem, yeah, no issues, you get it. And this is my feature which you're going to give now, this point. So I'm going to give this one as 30, you get this one 30. So this is your operation in terms of corner. Are you guys with me? Please let me know. Are you guys with me? Yeah, please. It can be done. Just a minute. I'm just checking that one. It can be done. I'm going to get into my file, new. I did this operations right. I just made these points right, one by one. I just made switch off this sketches right. That could be the reason it is not allowing. I was doing this operations right, one by one. So that is what's not allowing me. So now let's go into it. It should happen. Go to the sketch point. Take this one, take this point and this point, and go for constraint. It is happening, right? This is what you're asking, correct? Yeah, this is what, yeah. So I was switching on, switching off, right? That's the reason it was not accepting it. Yes, it will take that. Now you go and give the dimension. So in this case, I can just give this dimension, and I can give this dimension, and select these points. One, second point, third point, and fourth point, and go for this same chunk and give this value for 25 mm. Give this one, get this one. Yes, you get this value. So the moment you do it, so the last, see what happens, default, if you see, whenever you create these formulas, relationships happens here. You can see on the specification tree a formula is created, right? So same thing which I did it, same elongated hole when I did it, always you will have this challenge. Same thing it was happening for me, because when I just drew this line, it was not constraining because I was making switch off, switch on, right? It will be there in a catch. So now you just move this one, see, it is not moving out of that position. So what we need to do, now in this case, I would like to constrain this one. So what are the ways to constrain? Number one, first you need to give this dimension, right? I'm going to give this dimension to 140, 150, perfect. And this one I'm going to give this to 25. I get this one. How to constrain this one? First, let me draw an axis system from here, put it normal view, and just from here draw an axis through which one it's going through. Right. So now, if a moment I just move this one, that also is not moving. See this is not moving. So what I'm going to do, select this point and control and select this particular point, and then make this vertical axis and go for constraint definition box and give symmetry. You get this one. And that moment you move this one, see that, now you can see the constraint is happening and this profile is happening. Now you know how to give the dimension between this one and this one. So these are some of the things which you need to know, how to give constraint 40 degree. So now you just keep moving this one. Because of the symmetry, whatever you have created, it happens. See this, that's a point which you need to understand. Okay, so now these are some of the operations and some of the profile creations which you need to understand. Now let's get into the deep dive and understand what are different types of operations you are having. For example, in this case, I'm going to teach you something called trim, breakout, and quick trim, and you're going to have closed. These are the things which I'm going to teach you now. Observe this carefully, alright? Observe this carefully. That the same operations will be there in the sketch analysis as well, right? The same operations will be there in the sketch analysis as well. That's what I was showing that. Now let's get into this one. What is my quick trim? So for example, I have here trim. That means I have a line over here. I'll just get it into line. So this is my line, one line, right? I have another line. See this? This is my other line. I would like to do a trim between this one. So I would like to do trim between this curve and this one. You get this one. Any other operations? See this? I would like to do a trim between this line and this one. You get this one. Any operations you can just keep it, right? This is why you use it, trim. Then you have other one which is called as breakout. I would like to break the entire line. Now if you see the dimension of this line, it is, say for example, 200, right? Can I break this line using this point or this line, vertical axis or vertical line? So select this line, make it vertical. I would like to break exactly this line at this particular point using this line. So what I do, go there, from here to here you can able to make it dimension, or else what I'm going to do is that I'm going to break the entire line, yes, using this particular line. So that means this becomes one entity, this becomes one entity. That means now you just go and select this one, you get this dimension, right? So that means you can use this breaking line to break any lines, whether it is a line or plane. Even with the plane also you can break it. Say for example, this entire line I move it and I would like to break with the reference to this plane, right, the axis. So what I'll do, select this line, select this point, this break, and select this one. Yes, I would like to do it. Select with reference to this one. So this you can able to see that I've just broken the entire line into two entities. One is this and one more is this one using this point. That's the reason you can see this one as one and this one as one, right? So this is one thing which you need to understand. And similarly, you have something called quick trim. Just go Control Z, right? I would like to break this one. So quick trim is very useful, powerful. So I'm going to use this one. See, quick trim. You can just double click on it. Just click whichever the components you would like to have it trim, right? All these components can be trimmed. Very powerful tool, right? And then we are going to understand some of the features. Say for example, closed loop. See this one. I'm just going to close it, and I'm going to use a profile here. See this, putting a normal view. Put normal view. Intentionally I'm going to draw the circle. See this, I'm going to draw the circle and make the circle. Yep. And I'm going to give this dimension. I'm going to give this dimension. And you feel that this sketch is fully constrained, right? 70 mm. The sketch is fully constrained. You feel that. But the moment you go and create your pad feature, see, I'm going to create my pad feature, you can able to see, right? If it is a complex design, you can't see this. And this is coming because of the reason my geometrical set is there. Somebody was asking this point yesterday, so make them, I'm going to cover in the later stage, because pad feature will not come under geometrical set, it is going to come under part body. That's the reason it moves on to the part body. I'm going to cover it, don't worry on that one. So the moment I go and select the sketch, you get a warning message that this sketch is not going to happen because of this gap, right? This because of this gap. So how to fix this? Now go to the sketch, the same sketch. It's fully constrained, but go to the sketch analysis, right? You have a sketch analysis. Go to the tools, go for sketch analysis, and you can see this sketch is fully constrained. The sketch is open profile, and starting feature cannot be open profile. We all know that. To make it close, what are the options you are having? You have options like closing here, right? You have options like close arc. You can close your arc here. The same arc, you can just see this, right? What I'm going to show you here, this one, right? See this one and this one both are same. What is the sketch analysis operation? It is like a doctor. It diagnoses and tells you that there is a problem of your sketch because of which your pad is not operating. It's not creating. So what we should do in this case, I would like to make this profile to close. See this, I'm going to make this profile to close it, get closed, right? That is very much important part. Okay, the moment it got closed, you get this one, and now you can able to go and exit and create this pad, whatever the pad feature. So it goes default to your part body. Don't worry on that message. Right. Now in this sketch, I'm going to make some profiles. So let's go and understand the next level of what is construction element. Okay, let's get into this one, the same sketch which I did. In the sketch, I'm going to create some profiles. See this, I'm going to delete this sketch. Once again, I'm going to draw a fully circle. I'm going to draw a circle, and I'm going to give the dimension of the circle 150. Now for this circle, what I'm going to do, I'm going to just draw one more circle. See this. Okay, and I'm going to give this dimension, and this is my pitch circle diameter. Okay, I'm going to make it as 100. And you can have your axis system. I'm going to just draw an axis system over here, right? And I'm going to have one more axis system, just to make you understand. And just draw n number of axis system. So I'm going to create a circle on this one. See, I'm going to create a circle on this one, and the dimension of this circle is, say for example, 20 mm, right? Now, like this 20 mm, I would like to place it in each and every point of this one. So on the axis system, I would like to place it, right? So the moment I would like to place, what I'm going to do in this case, I'm going to use an operational feature, something like this, where I'm going to use an operational features. I'm going to rotate. Rotate which one? I'm going to rotate this circle, right? I'm going to rotate this circle with reference to this point. How much I would like to rotate? 1. I'm going to create this one. See how much I would like to rotate. I would like to rotate 4. How much you would like to? And I would like to create exactly on this one. So you create it. So that means your profile has to be fully constrained. See this is my profile. So once again, I will teach you. Rotate this profile, this sketch, the reference to this point, right? Sorry. Take this one, rotate it with reference to this point. This is how many you want, you can just create it. 2, 3. I would like to create 3. Right? Now let's go and give the dimension. I'm going to give this fix. Let me give the fix, constrain this one, and I'm going to fix this one. I just fixed it, just to make you understand. I can make this fix as well, right? Fix this. And I'm going to make this fix. Now if you would like to create this one into solid, right? You know that it's not possible because of the reason self-intersecting sketch happens in this case, right? This self-intersected sketch is so dangerous in terms of the design of the base feature. You can't afford this one in terms of the design. So what do you need to do with it? You need to go and analyze your sketch. Go to the sketch, double click on the sketch, understand that the sketch has a self-intersecting sketches. So what we should do in this case, I would like to do a sketch analysis. In this sketch analysis, everything is closed, no worries. but you have a self-intersecting sketch. See this is my sketch 1, sketch 2, this is my sketch 3, sketch 4, all these are sketches, right? But my sketch 12, which is nothing but a solid line, which is nothing but your pitch circle diameter, PCD, which we used to call that, needs to be converted into a construction element, right? The moment you would like to convert into construction element, what is that option you are having? Yesterday we discussed. It's a construction element. The same thing is available over here, right? You just see this. The same construction element is available over here. This both are same. This one and this one both are same. So what I'm going to do, I'm going to make this sketch, this circle, as a construction element and give OK. Now the sketch is fully constructed. I mean fully constrained. Just give it OK. You can able to create the solid. And now we create a pad. You can able to create the pad as well. So this is one of the very important things which you need to understand, that construction element has to be given as a construction element. So now the sketch is completed. This message, why it came, I'm going to cover you this later stage. Somebody was asking. The moment you give pad, this message comes. The current in work object isn't it a body? The new solid feature is created after the last feature of the part body. No problem. It's not currently. You need to understand what is underline. Underline means it tells defined in work object. Defined in work object. Sorry, defined in work object. But geometrical set never accepts part design feature. Never accept part design feature. What is that part design feature? Pad, shaft, everything. So that's the reason it is telling you that it will go to the part body. No problem. You can go to the part body. And now you just give OK, select the sketch and give it OK. You can create this pad. Right? So this is the second very important point which you need to understand while creating the design. So this is my first feature which you should understand. So what we understood, I just gave a simple orientation because I will leave to you people to understand what is. I'm going to cover down the line what is the use of the shill out edges, all the stuff. But yes, for you at the moment, profile, rectangle creation, profile, all these are very user friendly. It's not a big thing. You can just practice by yourself and understand this concept whatever we have done. Okay. So today let's get into the sketch base feature. That means right from the pad, pocket, all the stuff, let's get into that one. So let's get into the first exercise of what we are going to do today. I'm going to close this one. Sorry. I'm going to close this feature. Fine. I'm going to close this one as well. Are you guys with me? Please let me know. Any doubts? Any doubts so far? Any doubts? Please ask me. Any doubts, please? Okay. Bhavesh, circle gets circle closed. What is meant by error name impact and close? Okay, I will tell you that one. Okay, I will proceed. Okay. So in this case, what we are having? You are having this sketch, two sketches. This is one sketch and this is one sketch. Let's go and analyze the sketch. This is my profile, right? And you have this one as my profile, the other one. The first thing what you need to understand is that when you start creating a sketch base feature, where is your sketch base feature? This is my sketch base feature. And always your starting feature is your pad, shaft, or a rib, or the multi-section solid. And always understand that when you start creating any of the sketch base feature, the first objective is your sketch should be fully constrained. So let's go and analyze the sketch, whether it is fully constrained or not. Go to your sketch, tools, sketch analysis, and it tells you that this is fully closed, right? Implicit profile, closed, fully closed. Okay. So now let's get into the next one. The next sketch. This is my other sketch, which I'm going to use this pocket. And this, just go and do a sketch analysis. And that is also very good. Close profile, no issues. So this is the first step which you should do always. Then, I'm going to make you some very important factors which you need to understand. First, pad. The purpose of pad is to create a feature of any dimensions based on your profile which you have done. That means it's a sketch-based profile. Observe here, the moment I select this pad and select the sketch becomes default parameter. Say for example, just see this. I'm going to create this pad using the sketch 1 and I'm going to give 5 mm thickness mirror on both the sides. You get this one. That's a possible. That means default your parent becomes hidden and child is visible for you. The sketch becomes hidden on default. That's the algorithm. Some point of time you decided, hey, I just did this sketch. What is the parent of the sketch? See this. The parent of the sketch is XY plane. I did this pad and later I analyzed that, hey, this pad is supposed to be done on YZ plane rather than XY plane. No need to delete and do once again. Not required. So see the parent-child relationship, this parent-child relationship, very important always. Whenever you are struck with errors, message, all the things, you just go with parent-child relationship. This is my pad, just go this one, show the parent, this is my sketch, make a show of this one, and this is my XY plane. So this sketch is done on XY plane. But my requirement is, this sketch is supposed to be done on YZ plane. We made a mistake. So what do you have to do? This sketch has to be moved to YZ plane, right? The sketch requires to be moved to YZ plane. That means what I'm going to do in this case, you just see this. Right click on the sketch, which you want to move it to YZ plane, and go here and do the sketch 1 object in the last and change the sketch support from XY plane to YZ plane. See this, to YZ plane. The moment you change it, you get this one. See that I just changed this one and it gets updated. Just update this one. Probably your sketch is not done and this sketch is there. Delete this one. So now you see that I just changed my sketch as well into this one. That means I just moved this sketch from XY plane to YZ plane. And similarly, you need to move this one as well, right? Change the sketch support, this one, yep, exactly, this one to YZ plane. So this also does. Give OK, that also moved it. See this? I just moved it. So no need to worry. So now you go and check your parent-child relationship. Your sketch is done on ZX plane, for example. If you want to just change it to YZ plane, so just go there. Show the parent-child relationship, you can just see this one. Go there. This is my sketch, which I would like to change it to YZ plane as well. Now go and select my YZ plane and give this profile and just give this profile, it gets selected and gets updated. Okay, so that means the moment you want to change any of the feature to the different control that I just made it, you can just change your sketch profile as well. So that's a point which you need to understand while designing. So just I'm going to make it pad in reverse direction, give OK. Right. So now we have created the sketch. Now I like to create a pocket using this sketch. So let's get into this one. Now pocket this profile with reference to this one and just give OK. Get your profile as well. So this is my sketch which I just use this pocket. So the moment you start building your feature one by one, you see that I'm building my feature one by one. So that means the moment you make pad defined in work object, always people get confused with this one, defined in work object. What does that mean? I'm going to make it defined in work object. That means currently you can able to see only the pad, even though the pocket is visible, feature is created. You can't see that. Now you create define in work object. This is your second feature which you need to understand. Okay. So now we learned how to create a pad using the sketch, and we know how to create a pocket. Material addition process, material removal process. Now let's get into this one. How to create a hole. Very important. I'm going to create a hole on this top face on the other side. For that, what I need to do, I need to select the top face, right? I need to select this top face. That means I'm going to select this top face and select the point where I create, the point which I click becomes your position sketch. See that? That becomes your point of your hole. That means the center of the hole. I'll repeat once again. I would like to create a hole exactly on this one, right? The point where I click becomes the center. But the center is not exactly constrained. That means the center can fly anywhere in the space, right? It can fly anywhere in the space. That's our objective. Always our sketch has to be fully constrained, right? No worries, you have something called position in sketch. You have something called position sketch where you can able to use this position sketch and constrain the center of this point with reference to this particular edge or axis, right? So let's go and give position sketch. Okay, I'm going to select this one, this point, and I'm going to select this outer edge and go for constraint definition box, right? Select this point and this outer edge, go for constraint definition box and give it concentric. The moment you give concentric, you can able to see concentrics. Give OK, you get this one profile. So now your profile is exactly concentric and it is fully constrained. How you confirm it is constrained? See this? The moment you go there, it is green. The green, yesterday also we discussed, green means it's called as a fully constrained sketch. It has to be fully constrained sketch, right? Go there, exit this workbench and do it. I'll repeat once again. This hole is always having a confusion. Just go there, delete. I'm going to delete this one, right? And I'm going to hide the sketch as well. And I'm going to select my hole first. Select the face where I would like to create it, right? And go for a position sketch. The moment you get into position sketch, you select this point, the center of the point of the hole, and use Control key and select the edge. And your constraint definition dialog box appears. And then you give constraint, coincident constraint, you get fully constrained, concentric, and give OK, you get fully constrained. Okay. Now you exit the workbench. Your sketch is fully constrained. Now you have different types of threads. You have different types of threads, right? One is blind. I'm going to discuss more on this tomorrow. Then you have something called type, a simple type, a counter type, right? A simple type, tapered. Taper means you can able to give this angle. See this, I can able to give this angle. You have counter bore. A counter bore with a diameter. You can able to give this diameter. Counter sunk, right? You have different counter sunk, and we have counter drill as well. So we are going to discuss more on this one tomorrow. So let us take in this case, it's a simple drill. Give OK, and I'm going to give the dimension until 10 mm. So your drill is also done, hole is also done. So now, if you see this is my sketch base. Even to make my hole, right? To make my hole, I need to have my sketch. So if you see all this pad, sketch base feature. Pocket needs a sketch. Hole needs a sketch. Now I'm going to cover something new, which is called a dress up feature. This is my dress up feature, where I'm going to select my fillet. So I'm going to select my fillets on the top. So before doing the fillet, I'm going to select this edge and going to select fillet first. I'm going to give fillet of 25 mm there, something like that. I just give fillet there. There is a meaning of selection of this edge. Tomorrow I'm going to cover more on that, right? Tomorrow I'm going to cover more on that one. How I'm going to give, why I selected this edge first. And I'm going to discuss more on the best practice of how this pad, pocket and hole and the draft. I'm going to discuss more on that one tomorrow. Now what happened? I just created the feature and I would like to create a fillet on the top face, top edge. So I'm going to select this edge. I'm going to give, say for example, 10 mm. Sorry. not 10 mm. I'm just going to give this 2 mm. Preview it, you get this fillets. And give it OK, you get this fillet on the top. Similarly, I would like to give fillet on the bottom side. No need to select once again and do it fillet, not required. Any feature you want to do it as a continuous process, double click on this edge fillet. Which is the fillet we selected? This is my edge which I selected for fillet, right? 2 mm. Now I'm going to select my bottom edge as well. So 2 elements are selected. You can see edge 1 and edge 2. And give OK, you get this fillet. So this is your feature which you need to understand first. So what we did, we just understand what is pad, what is pocket, what is hole, and what is the purpose of this edge fillet, and what is the purpose of this edge fillet too as well. So to sum up what we learned today, we understand some of the sketch based operations. So let's give a small process of what we learned it so that you remember those topics what we covered. The first thing what we understand is the moment you go to sketch analysis, right? We understood what is meant by sketch analysis today. We understood what are the profiles and what is the implications of making this switch off, switch on of the sketch tools. And we understood some of the profile, elongated hole, circle, axis system, all the stuff. And we understood what is the purpose of this corner, and the same way chamfer you need to understand. And we understood what is the purpose of a trim, breakouts, and quick trim and close one. And we understood what is the importance of doing a sketch analysis and doing a corrective actions, right? And then we understood, then we went to the part design and started very fundamental pad. We just understand what is meant by pad. Tomorrow I'm going to deep dive once again. We understand what is meant by hole. We understand what is meant by pocket. And then we went with the fillets. So with this, I will end for the day. And if you have any doubts, please do ask me.